machine learning in the cloud. I'll go ahead and do a quick introduction first, and we'll get deep into the content. My name is Joseph Holbrook, and I've been a blockchain and a cloud architect for quite a while, probably about 10 plus years now, blockchain a couple years. But before that, I did a lot of data storage and data analysis, for that matter, database administration. So I've been pretty much all over the map of the cloud and also on-premise implementations. So I'm based out of Jacksonville, Florida. I'm a published author as well as a U.S. Navy veteran. Some of the options around machine learning in AWS, Azure, and GCP. And I'll also talk about IBM as well, to a degree. And I'll also get into basically TensorFlow as well, and how that plays into machine learning and all that. I'll also, of course, get into some of the common terminology like predictions, or basically, also I'll talk about APIs, because you really can't talk about machine learning without really getting into understanding like the natural language APIs, or the speech or translation, and all these other options that are available. Also get into basically speech to text, and if time permits, I'll talk also about some of the options available for like Alexa and Google Home, or whatever it's called now. But just be aware too, we'll get into what the salary range is for a machine learning expert. I'll also talk about the role of AI and machine learning in the field of data science and data analytics as well. One of the common confusion areas is that a lot of folks sometimes will confuse AI and machine learning. And I'll go ahead and clarify the differences. And then I'll get into how it fits into the whole data science arena as well. Now, did you know that TensorFlow Research Cloud program enables researchers to apply for access to a cluster of more than 1,000 cloud TPUs? Also, I do have a demo I'm going to walk through on TensorFlow, what's available real briefly. And then I'll get into options available on Google Cloud as in the Cloud Console as well. Let's talk also about, we'll talk about briefly too, how we can correlate the differences, for example, in options in the cloud. I'll also discuss, for example, how data scientists can stabilize their data and use machine learning as part of that. Like, for example, predictive analytics, for example, is commonly referred to. And then we'll talk about some of the hurdles that we might run into with adoption as well. Before we get started, let's talk about QuickStart. QuickStart is a global IT training company. We offer online job-ready boot camps in collaboration with universities and colleges. Some of those are listed here. So what exactly is machine learning? Machine learning, from a dictionary perspective, is really defined as the process, or the practice, I should say, of using algorithms to extract data, learn from it, and then forecast future trends for that topic. Excuse me. Now, it's important to realize too that machine learning is a subset of AI as well. Machine learning and AI are really just a part, or a parcel is another way it's referred to as well, of data science. So we could have data science without machine learning or AI, but it might not be as effective. On the other hand, we really need to consider machine learning and AI really part of the data science profession is another way to look at it. So what's the difference? When we look at data science and data analytics and AI and machine learning, one of the things I want to point out too before I forget here is that, again, we know that data science is really at the top layer, and then we use data analytics basically to utilize AI and machine learning to really help us derive value and also solve problems. And I'll talk about what the how and the when and why and how that all really comes into play. Basically, how do we ask questions and understand, how to figure out the answer. Now, what are some of the benefits of using cloud ML and AI? Now, I think it's also important as well to appreciate that when for example, we consider like using the cloud, there's always that, I like to call it the CapEx and OpEx discussion. And what that means is, if we were going to go out and invest in like our own infrastructure, for example here, it wouldn't be a pay-per-use model, it would be like a dedicated model. And the cost of that would be just exorbitant for a lot of organizations. Because we're using the cloud, we could spin up, for example, services like Amazon Machine Learning or Azure Machine Learning Studio, or even IBM Watson, for example, and actually start looking at regression or anomaly detection. If not every ML service supports like anomaly detection, but the one that really does is Azure. That does that really well. And also too, like we commonly would run into like, I guess the way to look at it is like a recommendation. Like if you've ever gone to like some of these websites, like Amazon, for example, is probably the best one out there, or Target is another one. Like if you go to like a retail store, or retail site, I guess, if you go there, you type in an item, and you know how it'll pop up like the item you're looking for, and then it has these recommendations as part of that. That's typically a recommendation engine where it's popping up basically as a result of your behavior, other suggestions that you might want to add into your cart, for example. And that, of course, plays into what machine learning and AI really bring to the table, especially like in retail. Okay, with a couple other things real quick, just around scalability. It is really important to realize too that scalability could be handled a few different ways in the cloud. It really does depend on like the cloud service, but also is it platform as a service, or is it an infrastructure as a service deployment? I'm going to talk about that. I have a couple tables where I compare the different services in a couple different basically comparison modes. Now, it's also, I think, a good benefit as well is that most of these services are supported in one or many ways on each of these major platforms. And of course, IBM as well. Constant upgrades is another thing. So also too, what I mean by constant upgrades is the cloud provider, of course, is upgrading their service. You know, if you're using like predictive analytics, like if you're using basically Amazon machine learning, Amazon is constantly updating their solutions, and of course, machine learning is one of those. For example, they may update the methods for pre-processing. They may update categories. When it comes to prediction capabilities with Amazon, one thing is they have typically like 3 classifications that are supervised. Actually, I think it's unsupervised. And then basically, they also have unsupervised as well. So they support both, it's just a little differently. One thing I have noticed is with like predictive analytics, excuse me, is that it generally supports, though, a limited number of APIs. And I think that's just one of those challenges that we have to deal with as a cloud professional or a machine learning professional. Also note, it's important to realize too that there's different delivery models. And what I mean is that the machine learning, for example, could be delivered through like cognitive computing, through automated methods, through models or model serving, but it could also be more like infrastructure as a service, which is like a GPU or FPGA based approach where you deploy a virtual machine and then basically what they're doing is extending over a GPU or an FPGA. And that's a solution that could work in some situations depending on what you're trying to do. Some of the other benefits is to help you as a customer address the why, the what, and how of analytics. And I would also throw in there when as well. That's another question you could also ask as well. But basically the three main areas that the cloud machine learning services really address is going to be diagnostics. So for example, why did it happen? If you have to look at, for example, some specific data, and this data just, is reflecting an outcome you didn't expect, you could go ahead and of course, use a service that might help provide some insight. You could also, for example, use, like in Azure, anomaly detection and figure out did something go wrong, or perform regression testing or clustering, whatever you want to do. But basically, with machine learning, excuse me one sec, my throat's acting up. With predictive-based analytics, basically we want to think about it from a perspective of what will happen. For example, one of the things we could look at is we could look at past data and then use machine learning to figure out what might happen based on the predictive models that we're using in that cloud service. For example, maybe we want to use, for example, a specific framework like TensorFlow, or we could use Spark. That is another common platform that can be used. But generally, we could use like mlib, or we could use another one that you see quite a bit lately too, is called PyTorch. So if you're familiar with like Python, this is a natural fit. But basically, prescriptive is what should we do? So basically, that's like, how do we solve the problem? So these are really the main areas, I think, around benefits. And I just want to sum it all up in the manner of to think about cloud services like this. Cloud services, when it comes to ML and AI, they really can help your organization move from an assumption-based, approach, basically decision-making process, to a data-driven organization. So if you were in an organization that would sort of like guesstimate, now with all the available tools in the cloud, there really isn't much of a reason other than maybe the cost or maybe on-site expertise, where you now should be able to not only look at data, but also basically ingest that data, run against those models, whatever you want to do, set up the appropriate categories, perform your processing, and then do what you need to do in the cloud service basically to help basically look at how can we solve the problem, but also how do we get the right data to make the right decision? And this is something that there's a lot of great case studies on, I think, out there, especially like with the tech companies like Google, Facebook. A lot of the financial sector has been using this as well. So it really just comes down to your organization saying, you know what, it's one thing to collect a lot of data and sort of run some numbers and guess. It's another thing to really take those numbers, bring them into some really strong and really intense, well-designed frameworks and tools to be able to take data and make an appropriate decision based on that data. So basically, it just comes down to you as an organization basically making a decision and using, you know, whether it's an automated solution or a semi-automated solution, it's really up to you. There's a lot of good choices out there. And we'll go ahead and talk more about that. So let's go here to a whiteboard and let me share my screen. And oh, where is it? Right there. Now, when it comes to AI and machine learning and where's my, give me a second, I forgot, close that. Okay, and thought I had some symbols ready to go, but I guess I did not. That's okay, I could easily draw it out again. Okay, let me do this. So here's the thing with the cloud. When we consider the cloud, it's important, first of all, to think about the cloud as a service model. So if we have like the 3 service models, which is effectively going to be SaaS, platform as a service, and then infrastructure as a service. And I have some tables comparing these here in a few minutes. But basically, we want to think of the cloud at least from this perspective. So the services in the world of the cloud is going to be typically infrastructure, platform, or software as a service. Now, typically machine learning, though, is going to be infrastructure or platform as a service. So this is generally where we would see most of the services. Now, if we think about it from this perspective, so let's just say here, I'll just draw this out this way. If we choose to, for example, let's just, let me just put this here, machine learning in the cloud, let's say, then we need to make a decision. Do we go with software as a service? Do we go with platform or infrastructure as a service? Okay, so the next layer here is to look at it from this perspective. Chances are with software as a service, we're going to want to use, for example, anything from vision to like a speech or language-based service. Also, too, there's other services out there like auto machine learning. And we want to think about it like, I'll just put this here real quick. And then speech. And then we also have language. So for example, maybe translation services. And then we might have, for example, vision. Another common use for machine learning now is to take images and start making decisions based on that image. And this is a very common capability that most of the providers support really well. Then platform as a service. So this is where it really starts differentiating. And that comes down to training, basically training models. Then we have tuning models. And then servicing is typically the other approach that we'd want to consider. So on the platform, we're going to consider training. And let me see, probably tuning would, yeah, tuning. And then generally some kind of service or server-based solution. And then infrastructure as a service. This is really, I think I mentioned this earlier, this would be sort of like you going to AWS and using EC2 and then effectively like adding on basically like a GPU or maybe a really high-end CPU or an FPGA, an ASIC basically as well. So that's really how that will work. Now, most of the value though for customers will come into play right here. This is really where the value seems to really come in, especially like if you're data and data analyst or data scientist. That's probably going to be where you're going to get the most bark for your money, I guess, is the way to look at it. Okay, now just to finish this up, generally, if you're a developer putting these apps together, you're going to be working typically a lot of the time in a SaaS-based solution. So this could be like TensorFlow or any number of other solutions out there. It could be, again, AWS, any kind of APIs usually. Also, I want to make a note, a lot of these are mainly API services that the developer will be connecting to. And then over here, we would have basically our data professionals. So I'll just put data pros here. And then over here would be, I'm going to put dev, basically. This would be like, basically our cloud developers or our application developers, typically application architects, whatever role. That's typically what you see those roles typically as. And then typically with DevOps, there's a small component there. Sometimes they fit in down here as well. But basically, here's the main thing to think about. To sum this all up is basically, if we go from the top here, this is going to make basically these layers a little bit simpler. And then as we go down, the more work your team will have to do. So it really depends on, I think, how hands-on you are. So DevOps also, I would like to say, is like IIC as well, infrastructure as code. Any questions on that so far? So in a nutshell, that's really, again, just the high-level layers. But again, just remember, we're going to use a lot of APIs. We're going to use different services. Some are managed, some are not. Some may be GPUs, for example, like down here. Some may be more basically automated services over here. Whatever delivery service model you want, chances are one of the providers will have a solution for you. Okay. And let me check over here. Any questions? I don't see any. Okay. Now, what about service options in the cloud? So I'm going to discuss AWS, GCP, Azure, and IBM. And I'm going to run through these services fairly quickly. If you have any questions, let me know. There's a lot to talk about here. And the reality is to talk about even one of these services could be a 2-hour discussion. But I did want to give you at least a high-level overview of how the cloud service providers actually provide you services. Now, one of the terms that you're going to hear in the industry is typically machine learning as a service. This is really an umbrella that encompasses basically any type of prediction model, pre-processing, even training model, etc. Typically, when it comes to like prediction results, we can bridge them together through typically a REST API. That's commonly where most of the services are going to be integrated with, is via REST APIs. Some do use open APIs as well, and proprietary depending on the service. Some of the common services out there will be Azure Machine Learning, Google Cloud AI, AWS Machine Learning, and IBM Watson. When it comes to infrastructure as a service, Now remember, infrastructure as a service is what? That's our GPU, CPU, FPGA, where we're going to deploy a virtual machine image like EC2, Google Compute Engine, etc., and basically deploy a high-end processing capability such as a CPU, GPU. Typically, it's going to be a performance CPU. It's not going to be like a run-of-the-mill Intel for sure. But basically, they typically would have an accelerator as well. So typically, again, these deployments can vary slightly. And I'll show you, for example, Google here in a little bit. With that said, FPGA is one of those common types that we could use for processing. Now, when it comes to machine learning provider services with infrastructure as a service, Google Cloud has what's called Cloud TPU. We wanted to use Compute Engine with that. And let me get my highlighter here. So for example, Compute Engine would be what we'd want to use with Cloud TPU. Now, EC2 is a service, again, I didn't note EC2 here because it states it directly in the name. But basically, it's called deep learning. Now, they use NVIDIA for the back end for their processing. And then Azure has what's called deep learning. IBM also has their own approach called IBM GPU. That's going to be deployed on the Bluemix service. Now, when it comes to platform as a service, basically platform as a service is pre-configured, whereas we know that this infrastructure as a service is not pre-configured. So to set up infrastructure as a service is going to, of course, give you more control over how you want it configured, but basically will take more, I guess I should say, deeper knowledge into the technology. With the machine learning solutions, generally they're pre-configured to do or perform or to, I guess the term I want to use is to basically help you as a customer determine how you want to handle your data. Like, do you want to process it, or is it processed already? Do you want to train it, tune it, etc., right? How is your data team going to address what really needs to be done? So the platform as a service, some of these are really specialized. Some of them support just about everything. On the other hand, some services may not provide you really good regression testing, for example, or may not have any kind of basically deep insight or logging capabilities or predictive analysis capabilities. Whatever that is, again, it just comes down to the service. Now, one more quick thing on this slide. We also want to be aware that we could consider, for example, the different tools that could integrate into the data preparation phrase, basically. Basically, what I mean by that is we could use, for example, cloud machine learning in Google and have some choices on how we prepare our data. We may not want to go directly into Cloud ML. We may want to go through an API and then into Cloud ML. Now, here's a table that sort of puts together some of the automated solutions. For example, here you could see that with GCP, Cloud Auto ML supports classification, regression, and recommendations. However, it does not support clustering at the time of writing, anomaly detection, or ranking, for example. So these are just some of the things we want to really consider. Now, Amazon Machine Learning does support classification, regression, and clustering, Azure is probably, and actually, you know, this is something that I do run into quite a bit, is Azure typically does come out #1 in the platform as a service area with machine learning. There's no question about it. When it comes to features anyways. Now, there's, of course, a lot of things that it doesn't support the same way as maybe Amazon or GCP might. And then we see Watson Model Builder only supports classification and regression. It actually has really no capabilities around clustering or ranking for that matter, or anomaly detection. And then when it comes to custom modeling, this is where we could use, for example, Google Machine Learning Engine and use, for example, TensorFlow. We could use TensorFlow, of course, with any of these services. But for example, again, we may want to use a Spark-based framework or a lib-based framework, or we might want to use a Python-based framework. And each of these will support those a little differently. AWS, we have SageMaker. Azure, we have machine learning services. And then Watson Machine Learning Studio. So as you see, when it comes to frameworks, they all support TensorFlow. And the reason I'm bringing that up, and I'm going to go walk you through a few things on TensorFlow, just as a brief review, is, again, TensorFlow is by far the most widely supported framework when it comes to machine learning. So why is TensorFlow really so important? I think one of the reasons that it's really widely used as well is because Python is, again, really supported really well. Python, as you may know, is one of the most widely used development languages out there right now, and one of the most popular, and perhaps the most in demand, depending on what you're looking for. So whether you're developing in a new SQL-based applications, or you're developing in machine learning or blockchain, Python is likely supported at least 10 different ways in what you're looking for. This, of course, is vastly different than the support you might get in other languages like C++ or something of that nature, or .NET. Now, okay, so in case you're not familiar with TFRC, the TensorFlow Research Cloud is actually a really interesting program if you're at like a university and you're really in a program that is using AI and ML to really dig deep and ask the right questions, again, against your machine learning requirements. And also too, one of the things about TensorFlow is it does have a widely popular, actually, library that is out there. And then as far as when it comes, excuse me, my throat is acting up. As far as, let me see what slide I'm on. Okay, so as far as TensorFlow 2, it is, of course, a machine learning library. It has a wealth of tools available. So for example, we want to think of TensorFlow basically as a language that we could use to really learn and understand basically how we could basically bring together our requirements basically for computation around machine learning. TensorFlow basically will allow like developers, or it doesn't have to be developers, it could be anyone who wants to play around with it, to basically design what's called a flow graph. Now, a flow graph, like, for example, in the world of TensorFlow, is similar, I guess the way I'd like to compare it is really like a mapping. So basically, when we use TensorFlow, it basically is going to allow you to design basically a data flow or a mapping so that the structures that you want to define will basically do a few things sort of similar to this, where you want to not only, I like to compare it to almost like in the back end, like NSX virtualization or something, where you're basically mapping the physical layer to the virtualized layer. And again, the way we want to look at it is these structures will define how data moves over what is called a chart. And then we want to think about it as a series of processing nodes. Also, if you're not familiar too with TensorFlow, basically there's also two terms I just want to clarify. So for example, when we talk about TensorFlow, we typically talk about tensors and nodes. Now, basically, we want to, for example, think about, for example, TensorFlow as a way for developers to really bring together all these tools to really utilize in any number of ways to process data. And it also has layers of, I guess, what I would call fault tolerance and all these other really nice benefits. And let's see here. There's libraries are targeted towards software engineers, of course. And then also too, if you didn't know, Google TensorFlow is actually the name of it, but they like to refer to TensorFlow as sort of like an independent organization, but it's actually a Google-based service. All right, so what I'd like to do now is go over to the TensorFlow site, and let me save that. Now, if you go over to tensorflow.org, one of the things that I like that has been done by the TensorFlow organization is that they provided beginners some really simple examples to really dig into basically the APIs and then also the framework and essentially the libraries as well. So basically what you could do is go over to, I think it's right here, tutorials, and they have different quick starts, and then they have the notebook. So basically in machine learning, there's what's called a notebook. Some platforms will support, like Jupyter is typically one of the more common ones. In TensorFlow, it supports, for example, Keras is basically a collection, as they would be called. And basically what this is going to provide you like basically a palette. Now, what's a palette? It's like if you're a painter, it's that like whiteboard that you use. So that's another way to look at it. It's like a whiteboard. What it's going to do is take the collection and then demonstrate basic tasks on a whiteboard for you. And that's called Keras. So don't get confused by some of these terms. Now on GitHub, there's of course the data sets and the libraries and all kinds of different tutorials as well. And if I go back to the home page, I go over here to get started with TensorFlow and then go to tutorials. And you can see here that if I scroll down, there's TensorBoard. And I could run TensorBoard. So what is a TensorBoard? It's really a tool that you could use to really start understanding, for example, the modeling and basically some of the syntaxes, data sets, etc., and how it sort of comes together. And it basically runs two different ways. You can run it in Colab. When I hit Colab, this is going to bring up basically a browser-based environment. And I think you could go over here. Yes, yeah, here it is. So you can see here, connect to the hosted runtime. This will allocate basically a minimal virtual machine that's running basically via an API, via your Chrome browser, to the back end of TensorFlow. So it's really a really cool resource. So a couple of things to point out, and they changed this since the last time I looked at it. So basically, if you scroll down here, you'll see if you highlight, that's really irritating the way they get that. Let me see if I could fix that, make that bigger for you. Okay. Hopefully you can see that a little better. So if you see here, we have RAM and disk. This is connected basically to Google Cloud Compute Engine. So it's running a micro virtual machine in the back end, and you're essentially using the browser as an interface. And what we could do here is go down here and we could run what's called a cell. So this is called a cell right here. Excuse me. And if I want to run the cell to see what will result, I just select that arrow. When I click, or I could go Control Enter, you'll see that it sort of made that little circle. So I hit that, and then basically I could download this, I could link to it. I could also change the config if I want. See here, I could log in and add to it if I want. And then I could go down here after I'm done and then run this basically. And you can see there, that'll import. Then hit that. And then you'll see it'll bring in basically this data set right here. And then here's the layers that it will use for Keras. Remember, Keras is what? That's basically that whiteboard that we could look at. So it's downloading the data right now. And if we want, we could go ahead and click that and download that, that data directly as well to an MPZ file. And you can see there that it's just about done. Once this is done, I can then use a model as well on the tensor board. You see there, I can just keep on going with this. So there's a lot of what I call capabilities. Another thing too about TensorFlow is that I can also, for example, with the libraries, access those via TensorFlow if I want, but I could also use Python directly if I want as well. The applications, for example, of TensorFlow, we can operate basically on any target we choose. Also too, a lot of people don't know this, but you could also use this on your Android device if you want. Now, when it comes to TPUs in Google Cloud, basically that's called a TensorFlow processing unit. This is something that was developed by TensorFlow to run basically on Google Cloud. And then if we scroll down here, there's additional areas that we could dive into. For time purposes, we'll need to continue, but if you see here, this is our tensor board. So when you get done, you go ahead and basically bring up your tensor board, and you can change this however you want as well. And then it'll allow you to graph it out. And then when you're looking at this, this is actually looking at basically regular expressions if you want. We can ignore or add in outliers to this if we want. And then we could also perform smoothing on it as well. So these are just some of the things that we could look at. Now, as far as the dashboard, it tells you more about the TensorFlow dashboard here. And again, if you have like an hour and a half, this is a really good exercise to go through. Now, what about the role of AI and machine learning in the field of data science and data analytics? It's important to know too, we already know that AI and ML are really a subset, specialization of data science. And generally with AI and ML, using basically ML, for example, this is really important, for example, around predictive analytics, regression testing, etc. ML is really a subset of AI, And it's basically a diverse set where essentially it's really meant to bring together data science in a way that wasn't really possible a few years ago. And the goal of machine learning is to basically handle data without anyone telling it what to do. When it comes to different jobs out there with data science, machine learning engineers are the most highly paid generally. And the average salary that's been reported, for example, on, I believe, Glassdoor, was about 131,000. And I've seen examples of machine learning engineers sort of stating the salary could go up to 200K. So very substantial if you are really good at math, if you're really good at analytics, you're really good at solving problems, this is a career that could be for you. Also too, remember too, training your team is really important. Quick Start has numerous options around machine learning and AI that you might want to consider. Now, before I put it together, I did want to go over to the console in Google Cloud. Now, we have about 15, we have a little bit of time. So what I'd like to do now is go over to the Google Cloud console. And well, let me sign into a different account. I think it's this one here. I had a few things set up. And in this, for example, here in this Cloud Console, you can see I have some services running in this project right here, and then I have another project here, two others. But basically, let's say, for example, if I want to go over to basically additional services in Google, down here near the bottom, we have what's called AI solutions here. Now we have the Vision API, we have the translation, talent solution, we have the AI platform over here as well. And then again, we scroll up and look at other services that are available as well. Now, also too, if we go over here to, let's say, AI platform, we go to the dashboard. One of the things we would want to do, first of all, is go over to what is called the AI Hub and start understanding basically what we really want to use and what we want to integrate with our machine learning and AI platform. When it comes to notebooks, there's various ones available as well. Kaggle is one that's also popular as well. AutoML, we have tables here. We have AutoML natural language. We have TensorFlow deep learning images. So this is actually something you might want to consider. If you remember that the chart that I went through around basically talking about the difference between platform as a service and infrastructure as a service, if you want to deploy your own image or a template with GPUs, for example, this might be a good solution around that. And you go ahead and just deploy a template based on that. So if you go to visit here, this will walk you through how to create that instance with TensorFlow. You can see here without GPUs. Now, again, there's some cost considerations here. I don't have the time to go too deep into it, but again, you can create one without a GPU and then add it later, or you could use basically one with a GPU. And if you use this, basically this is going to allow you to perform somewhat better and also customize as well. This is the instructions you would go through with Google. Also, too, it supports what's called a PyTorch instance and allows you to run your deep learning VMs with basically PyTorch. So PyTorch is, of course, a widely used tool in the world of Python. And again, take a look at it if that's of interest. And then over here, if I go back to the dashboard, if I type in machine learning, I could go over here and find any number of solutions that are available. So right here is the machine learning kit. And to use basically the machine learning kit, the first thing I need to do is enable this API. Once I enable the API, I will then be able to start adding other components to my services. Now, if I go back over here, one thing we could do is go over to the marketplace. And I believe if I type in, what was it? This machine. Yeah, so if you type in like machine, this will bring up different options around, for example, APIs. Like this is one of the popular ones, like the speech to text, Cloud Vision API. This is the one you want to use, for example, if you want to take images and basically look at, like, this is very commonly used with like security-based applications. For example, if you want to look at a camera, like you put a camera like in a city square, you're going to use basically a solution like this to start recognizing faces and recognizing basically what people are doing. And then you want to basically use this to start determining what exactly is happening here. Now, some of these APIs do have a cost as well. So these are some additional APIs that you may want to look at. And if I go over here to Compute Engine, I could go over here and create an instance. And you can see there that I have different machine family types. And if I go over here, you'll see that it has like platform and GPU. So if I wanted to deploy an infrastructure as a service solution, I could go ahead and select this. Now, I want to point out that GPUs are not supported in every region and zone. So we need to go to a region and zone where GPUs would be supported. So we also need to select the right image. So if we go over here, I actually go over here first. I think we need to go to South Carolina. And we need to do two things. Oh, you know what? Just quickly here. It's easier to look over here. Let's see here. GPUs, Google Cloud. Yeah, so it's only supported in like 4 or 5 areas, so I don't remember on top of my head in Google Cloud where they are, but let's figure it out real quick. GCPU availability. Okay. And the GPUs on Google Cloud, I believe, are, NVIDIA. And if we scroll down here, it tells you what is supported. If you want to use graphic workloads, this is their recommendations. Okay, NVIDIA is supported in these availability zones, number of GPUs. Now also note that you also need to go down and look at the region, and then you notice here, this is going to be the zone. So it may be supported in Charleston or Northern Virginia, but not in every zone in that specific region. So this is something to be aware of. And then this is graphic workloads. So again, you could go over here and just validate what's available, for example. And then if we go back here, we go ahead and deploy a new instance if we imported our own image. And then we can go ahead and select template. That's another different template here. And then I go add a GPU here. And I just want to double check. N1. So the tricky part here is you need to pay attention to the processing platform. So you can see here, it's not supported on the N2 series. In this case, in this region and zone, US Central, which is Iowa, it's only supporting on an N1, it appears. However, in different regions and zones, it's also supported on N2 in some situations. So it's all one of those things, you gotta read the docs, just determine what you really need. Okay, so this is a Tesla K80. And if I deploy 2 GPUs, this is what it's going to cost per month for that. If I deploy 1, and I'm going to go ahead and kick this off here, it's $254 a month. So basically, to make this quick, I'm going to go ahead over. Also, too, one thing to point out is that you typically do not want to deploy this instance as an instance that we can terminate, for example. So do not turn on preemptible, because this will really screw up your modeling if it turns off automatically. So please pay attention to that. And then it'll go ahead and create that VM, and that'll go ahead and bring that up. And we'll go back to that here in a minute when it's up. Now, when we consider, for example, the cloud providers, we know that there's a wealth of options around there around AI and ML. We also know that there's infrastructure and platform as a service solutions that are out there. Note that the software as a service solutions are typically APIs. And then the salaries we know for the specialties can range anywhere from 80K to 120K. I did mention that I've seen salaries on average about 130, for example, in some regions. Like, for example, Chicago, the salary was probably 110. New York City was like 130. San Jose, I think, was like 170. So it really depends on where you're located. I didn't look overseas or anything, so I really don't have a good idea of what that might be overseas. Now, also note, for those that are interested, Quick Start does have, in coordination with several colleges and universities, a data science and data analytics program. You may want to review some of the benefits and then contact an advisor to find out more. Here is an example of the curriculum for the data science program. And then the data analytics program is here as well. And again, you could look at this and see that, again, it covers a wide area around data analysis and basically storytelling, visualization, Python, etc. And again, the link for this information is here. There's a phone number if you want to learn more.